Hello, everyone. So, today we are going to do a very interesting topic called sequence and series, which is quite manageable, but there are sometimes very complex questions that come. You can expect at least two questions in every year, and we will again do it in three levels. One will be your foundation, where we will try to build and understand all the common sequence and what we need to know to tackle these questions. Level two will be previous year questions, and then level three will be where we will cover advanced questions. So let's begin with the foundation today. So first and foremost, any set of numbers will be called a sequence, irrespective of if they have any relation. For example, let's say I take some random numbers, and these are irrespective of what relation they have, they're called as sequence. And if I add all of these, it will become a series. That is the common logic, right? Now, let's look at what are the common type of sequence and what are the formulas that we need to know and what is the logic that we need to know. So first and foremost is very important series, arithmetic progression series, which is also called AP, right? Now, in this, we will always have a number, let's say the first number is 2, then something will get added to it, 3, 4, 5, 6. This is an APE because the first term is 2 and every term is getting increased by 1. So the common difference between every number is 1. So in this case, it's an AP. Similarly, if you look at this is also an AP because the first digit is 2 and the difference between every two digits is 2. So whenever there is a common difference between all the consecutive digits, it will be known as an AP. Now we denote nth term as T1 will be the first term, which in this case, let's say we assume this as our series. So T1 will be 2, T2 will be 4, T3 will be 6. So this is basically how we denote any Tth term. Similarly, sum up to n terms, so S1 will be sum of first term, which is 2. S2 will be sum of first two terms, which is 2 plus 4, 6. Sum of first three terms, which is 2 plus 4 plus 6, which is in this case 12, and so on. Now, this is one of the most important concept, which is also one of the favorite topics of CAT exam setters. If you want to find T3, you can take the sum of the first three terms and subtract the sum of the first two terms. So basically S3 is 2 plus 4 plus 6 and S2 is 2 plus 4. So you got 6, right? So any nth term you want to find, you find the sum up to nth term and subtract sum of n minus 1 terms, right? So this concept you can note down is important. And now about the AP. In general, can we say that AP will be first term is A, then some common difference will be added, and then again it will get added, then again it will get added. So this is how the series will look like. So AN is basically what I was assuming as TN. We usually write it as AN, and AN is A plus N minus 1 into D. How? Put any value. Let's see A3. So A3 is A plus 3 minus 1 into D, or A plus 2D. Our third term is A plus 2D. Similarly, find A4, A plus 4 minus 1 into D, which is A plus 3D. So this is something that we need to memorize, and this way of representing an AP we need to memorize, because this is how we will commonly denote it. And similarly, sum up to n terms, we have a formula which is n by 2, 2a plus n minus 1 into d. Or basic formula is a plus an. Because if you put an here, this is a plus n minus 1 into d plus a. So this is the second formula that you need to learn. Okay, these two formulas, then you can directly substitute an as a plus n minus 1 into d and get this formula. So we are memorizing these two. Got it? Now, if you look at the difference for any term, can I say take any term a plus an and then subtract n minus first term from that? Correct? This you don't need to learn. This is just a way of understanding that the difference. And similarly, if you take any terms, let's say you take mth term and you take nth term, somewhere in between, for example, mth term can be anything like this. Somewhere here can be the mth term. If this series goes on, let's say up to a plus n minus 1 into d, this will be the last term, right? If there are n terms, this will be your last term. Somewhere in between will be mth term and somewhere in between will be nth term. So any two terms randomly if you take and you want to find difference, simply this is Tm minus Tn. Now this is not the difference. This is a lot of something multiplied by that difference, right? Because if you take 100 term and you take second term, that it will not be D. It will be much more than D. So you divide it by m minus n. For example, in our previous case, I can find difference from any term. I can find 4 minus 2, 8 minus 6, 12 minus 10. Or if I want to say, let's say this is our mth term, this is our nth term, right? So if I find the difference, this is not the difference, right? But I know 1, 2, 3, 4, 5, 6. This is sixth term and this is second term. So this is what? 8 and this is 4. So difference comes out to be 2. That is the significance of this, and you don't need to memorize it. It just sometimes I want to share some formulas which are only shared for the logic basis, not for you to memorize, right? Let's go ahead. This is also very important that if I have to assume three numbers who are in AP, instead of assuming them as this, I assume as a minus d and a plus d. Why? Because most of the times when I add, this difference gets cancelled. So it's a very quick and very interesting way of assuming three numbers. Now similarly, if you have to assume five numbers, you can now see the logic: a minus 2d, a minus d, a plus d, and a plus 2d, and so on. Now if you have to assume four numbers, this is also important. How will you assume? Now don't take a as the central number. What we will do is we will take a minus d and a plus d, because the difference is what? 2d. You can see that a plus d minus a minus d is a, and a will get cancelled, d minus minus d, or 2d. So difference is 2d, and similarly go on the two sides as this and this. It doesn't come automatically in your mind. That is why we understand these frameworks, because most of the questions get easily solved. So these two you can note down, and I won't call them memorizing. If you understood it, the logic behind it, it will come automatically in your mind. So this is all about AP. Now we'll do some couple of easy questions so that we get comfortable with this arithmetic series, and then probably we will go about some more aspects of arithmetic progression. Now look at the first question. It is saying that what is the 10th term of this AP? 3, 7, 11, 15. Why is it an AP? Because the difference is of 4. 4 is getting added every time, right? Now, how do you write A3? A plus n minus 1 into D, right? This formula we have already understood. So, can I say A plus 2D? Similarly, if I want to write, this is the general formula, and A3. Now, if I want to write A5, just put n as 5, A plus 5 minus 1, 4D. Similarly, if I want to find 11th term, a plus 11 minus 1, 10d, and so on. So in general, whenever you get a question where you are talking about 10th term, simply write 10th term as a plus 9d, not more than that. You don't need to think beyond this. A you know is 3, and difference you can see is 4. So basically 3 plus 36 or 39. Correct? Now let's go find the sum. So this question is important because we need to get comfortable with the formulas that we have learned. So Sn is n by 2 a plus an, which means sum up to n terms. This is not nth term sum. This is sum up to n terms. So now if I need to find sum of first 20 terms, I can directly write n is 20, a plus, let's expand it. So this becomes 2a plus n minus 1 into d, correct? This whole formula usually is used like this only. We will put an as a plus n minus 1 into d, or you can directly write this formula. Now, as you can see, I can put n as 20. So this is 19d. And this is, can I put a value as 2? So this is 10. This is a is 2. And difference is of 3. Since it is already saying that it's an AP, I don't need to check. But every time you feel it's an AP, check with multiple patterns, 5 minus 2, 8 minus 5, 11 minus 8, to be sure that it's an AP. Now this is what? It could have been 60, but it is 19. So 60 minus 3, 57, 67, 77, 770 is your answer. Wait. I have taken A as 10, but A is not 10. A is 2 here. So this should be 4. So this is 57, 58, 59, 60, 61, 610. Got it? Again, before we move, there are some very important things that you should know. Any AP, again, I will take my standard AP for you to understand. I can add any constant. I can subtract any constant. I can, let's see if I can multiply and divide. But if you add any constant, let's say you add 1 to everything, right? Again, this is an AP. The difference just got added by 1. And if you subtract 1 from all the numbers, again, it's an AP. So one thing we can note is anything you can add or subtract, which is the constant, to an AP, it will still remain an AP. The difference will get modified. The D will get modified. But if you multiply it by, let's say, 3, so this will become 6, this will become 12, this will become 18, this will become 16. Sorry, I'm doing by 3, right? Yeah, 12, 24, 30. Now you see the difference is again same, and the difference which was initially 2 also got multiplied by 3. So you can multiply anything, still it will remain an AP, and you can divide anything, it will still remain an AP. Now if you divide it by 3, or let's say divided by 2, it will become 1, 2, 3, 4, 5, which looks like an AP. So anything can be added, subtracted, multiplied, or divided, and it will still remain a AP. So this also you can note down. Okay. So there's another very important concept, which is arithmetic mean, which is basically another name for average. So if I want to find the arithmetic mean of, let's say, A and B, arithmetic means formula is A plus B by 2 as the mean formula. So if you have 3, 6, 9, 12, and so on, and you want to find the arithmetic mean of all of these, it will be basically sum up to n, tn, or an. I'll use an, and occasionally questions might ask, give you tn. So be comfortable with both notations, they mean same. So basically this is Sn upon n. This is your arithmetic mean. Got it? But usually if there are two numbers, you will use this. If there are three numbers, you will use this. So don't keep learning formulas. Just understand the meaning of it. It's average. So I can say sum up to whatever the numbers are divided by the total number of uh, elements of that series we are using. Okay. I think there's nothing else that we need to know, but still there are some very interesting things that are very useful. If I find sum of first n natural numbers, sum of first n natural numbers, How will you find up to n? Basically, a is 1 and difference is also 1. So can I say Sn is equals to n by 2, 2a plus n minus 1 into d, right? This is basically 2 plus n minus 1 or n plus 1. So this is your sum of first n natural numbers. Sum of first n natural numbers. This also will come very handy if you can remember, great. Otherwise, you can quickly find it out. Got it? So this also you can note down. Similarly, if I want to find sum of first even numbers, 2 plus 4 plus 6 plus 8 up to 2n. Okay, so this becomes n terms because I am writing it. This is first term, second term, third term. So n term will be 2n, right? Now, what will be the sum? N upon 2. A plus an also I can do because I already know the nth term, or I can do 2 plus a plus n minus 1 into d. 2 and 2 will get cancelled, so this will become 1, this will become n minus 1 or n square. So this is basically sum of n even numbers. Got it? This also you can memorize, otherwise you can quickly find it out. Similarly, sum of first n odd numbers. How will we find 1 plus 3 plus 5 plus 7 plus and so on? N by 2, 2a plus n minus 1 into d. This will be what? See, this is very important. Most of the questions will be around assuming how do we notify it in a variable. So can I say 2n, but n, if you put 1, first digit is not 2, it's 1. So 2n minus 1. Can I say nth term as this? Let's see. Put n as 2. So this becomes 4 minus 1, 3. Put n as 3. 6 minus 1, 5. So this is correct. So here, if I say n terms, last term will look like this. Now, can I say n by 2, 2 plus 2n minus 2, or this is again n and n will get cancelled, n square. So sum of first n odd numbers. Got it? I think I need to recheck sum of first n even numbers. It can't be same. Sum of first n even numbers, I took n by 2. If I do n by 2, a plus an, this is n into n plus 1. Correct. This is basically sum of first n even numbers. But in this case, why am I not getting it? N by 2 is correct. 2a, okay. See, a was 2, right? So I've basically done a mistake. It's 2. So 4 plus 2n minus 2 or 2 plus n or n into n plus 1. This is sum of first n natural numbers. I hope this is clear. And similarly, first n odd numbers is n square. So there are three things that you can write down in your notebook and you can memorize. Otherwise, you can find it out directly. Sum of first n natural numbers, n into n plus 1 by 2. Sum of first n even numbers, n into n plus 1. Correct? And sum of first n odd numbers, n square. Got it? Let's go ahead. Another very important series is geometric progression, or we call it GP. Here what happens is every number gets multiplied by something. So first number is A, second number is AR, third number is AR square, AR cube, AR ki power 4 and so on. How? Let's see it with an example. 2, 4. Now next number will not be 6. It's not an arithmetic progression. It's a geometric progression. So everything gets multiplied by 2. 4 to the 8, 8 to the 16, 16 to the 32, 64, and so on. So here we, instead of difference D, we use R, which is common ratio, which gets multiplied. So R here is 2 and the first term is also 2. So now you can see how am I representing it like this. AR square, AR cube. Why 2? 2 into 4, 2 into 4, 2 into 2, 2 into 2 into 2, 2 into 2 into 2, right? So this is A into R, then AR into R. फिर AR square into R. So every time it is getting multiplied by R. So this is your geometric progression. And here also, if I want to write, let's say, any common term, AN, it will be A R to the power N minus 1. How? Look, put N as 1. This becomes A1 is equals to A R 1 minus 1 or A R 0. Anything to the power 0 is 1. So A. Put A2, A into R to the power 2 minus 1 or AR. Put A5, A into R to the power 5 minus 1 or 4. AR to the power 4, 1, 2, 3, 4, 5, fifth term. So you can see it's 2, 2 to the power 4. 2, 2, 3, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, so 32. This is your fifth term. Any time you get to know that, I need to find 17th term, it will be AR to the power 16. Okay, so this is your first formula that you need to memorize. You understood the logic, so it's not actually memorizing. Now you don't need to think that deeply. It should be your muscle memory that it should be AR to the power N minus 1. Now similarly, there's a formula for sum of n terms, which is basically AR square, AR to the power 3 plus last term will be AR to the power N minus 1. Why? Put N1, you get this. Put N, because we just saw na nth term. So this is how the sum is looking like. And if you look A common, it becomes R to the power 0 plus R to the power 1 plus R to the power 2 and so on to the R to the power N minus 1. Now, we have to memorize the formula, which is R to the power N minus 1 upon R minus 1. This is sum of n terms. Okay. And once you memorize this formula, you should also know there's a subtle difference between formulas depending upon R. For a series like this, where R is 2 or R is something greater than 1, this formula is making sense. Okay. But at the same time, this is also a GP. What is happening is you're dividing it by 1 by 2 every time. So 2 becomes 1. This becomes 1 by 2, this becomes 1 by 4, then 1 by 8, then 1 by 16, 1 by 32, and so on. So here, again, A is same, A is your 2, but R is 1 by 2. Every time A is getting multiplied by 1 by 2. So, since R is less than 1, the sum, it will all trail down to something very small because it just keeps on adding, but the thing that is getting added is very, very small, right? So this sum up to some nth term will be A 1 minus R to the power N upon 1 minus R, because R is less than 1 and this sum is positive. So to make it positive, it is 1 minus R. So this is also something to remember. If we saw GP in two terms, one when it was getting multiplied by something greater than 1 and the other when it was getting multiplied by something less than 1. And both the case, it was a GP, right? So now the thing is that sum up to n terms will, if I see it even further and if I keep on letting it go up to infinity, I know the last digit will be like a very big number and it will just keep on getting added, but at the same time I know it will be a very small addition to it, and at the end of the day it will become some whole number. So in that case, a 1 minus r to the power n upon 1 minus r, this r to the power n will be very, very small, which can almost be ignored. It will almost be zero. So r to the power n is non-significant and this becomes 1 minus r if n tends to infinity. So this is another thing that you need to learn. Sum up to infinity in case r is less than 1 is basically a upon 1 minus r. This is also because you've understood logically, you don't need to really learn. You can only learn this formula when r is greater than 1. When it is less than 1, thinking about the negative aspect, just put it 1 minus r to the power n upon 1 minus r. And when it tends to infinity, r to the power n is way, way, way small because r is 1 by 2, let's say. So 1 by 2 to the power 100 is 1 upon 2 to the power 100, which is very less, ignore worthy. So a upon 1 minus r. I hope this is clear. Now, similarly, as I was telling you, if you have to assume three numbers in a GP, how will you assume them? Just like we did in AP, A plus D, A minus D. Here, what you can do is A into R, obviously. Now, instead of A R square, I will assume the first number as A upon R. Again, if I play with them, R and R will get cancelled. That is the reason. So, whenever you have to assume three numbers in GP, assume them as not A, R and AR square, but assume them as this. Please note down in your notebook. This is also very, very important. Just like we understood arithmetic mean, we will also understand geometric mean. Okay. So geometric mean is basically what? Let's say geometric mean of A and B is AB to the power 1 by n. In this case, 1 by 2 or root AB. Similarly, geometric mean of A, B and C will be multiply A, B, C, put the power as 1 by n or 1 by 3. So, if I want to find n geometric mean of n numbers, then A, B, C, D, E, F, G, H up to A n to the power 1 upon n. So that is the geometric mean formula that we need to know. Got it? Now again, if I look at what I was understanding for an arithmetic series, if you divide every number or multiply every number by a constant, it will still remain a GP, which makes sense. And so on. If you divide it by 2, this will again remain a GP. The R, which was 2, now will become basically not. R has not changed. R is still 2. Again, every number is basically getting multiplied by 2. So this is also with logic you can understand. Multiply everything by 2. Again, this is a GP. R is still 2. So R has not changed. Common ratio is not changed. Now, if you add, let's say 2 or if you subtract 2, you can see it will not remain a GP. And so on. So that is the basic logic behind it. And similarly, if you subtract 2, you can see, first of all, in a 0 can never be a part of any geometric progression, right? But just to understand, you can see, so you cannot add or subtract, but you can multiply and divide by a constant and it will still be a GP. Now comes the third term, but before that, let's just quickly brush up our understanding through these basic questions. It is saying find the sixth term of this GP, 2, 6, 18, 54, and so on. Now again, as soon as it asked me for sixth term, I know it's a to the power, ar to the power 6 minus 1 or ar to the power 5. A is 2, R, you can just see R as any two numbers consecutive, you can see and get R. Now, 3, see, this also becomes a little calculative, but then again, you know that 3 to the power 2 is 9, then 9 to the power 2 is 27, and so on. So I will write it as 3 square, 3 square and 3, or 81 into 3, or 243 into 2, or 468, right? So this is also one of the way to tackle these powers. Find the sum. Again, sum of n terms we just learned. We can see that here r is basically 6 by 3 or 12 by 6. You can take any two. Usually even first two will work. So r is 2 and a is 3. So I know a, r to the power, let's write the whole formula, r to the power n minus 1 upon r minus 1. A is 3, r is 2, n terms, because I am finding for first 6 terms sum, 2 to the power 6 minus 1 upon 2 minus 1, or 2 to the power 6. So this you should remember, 2 to the power 10 is 1024. This is one thing that you should always remember, because if you want to find 2 to the power 9, you go backwards. That 2 to the power 9 will be 1024 upon 2. Okay, that is why we need to learn this. Anyway, so I know 2 to the power 3 is 8. So can I say 8 into 8? You know, right? 2 to the power 6 can be written as 2 to the power 3 into 2 to the power 3. Powers get added, right? So 8 into 8 minus 1, or 64 minus 1, which is 63, into 3, 3 to 9, 6, 12, 18, 189. Find the sum of first n natural numbers. Again, if you know the formula, we just learned that sum of first n natural number is this. But in case you forget, you know that natural numbers is 1, 2, 3, 4, right? And it wants me to find the sum, which is n by 2, 2a plus n minus 1 into d, or n by 2, 2 plus n minus 1, or n into n plus 1 by 2. You can always derive it if you forget. Now it is saying that the sum is 210, and if it is 210, then what is that n? What is that nth term till which the sum is 210? So again, this will become 420. This is n into n plus 1. You can make a quadratic, or you can also try to see it in factors. 2 into 210, or 2 into 2 into 105, or 2 into 2 into 5 into 21. 5 twos are 20, 20 twos are 40. 2, 105, 5 into 21. Let's again see if it becomes two consecutive numbers. Great. 3 to the 6 to the 12, 7 5s are 35. No, 5 to the 10, 10 to the 20 into 21. See? So can I write this as 20 into 21? Automatically n is 20. This is also one way. If it works out, great. Otherwise, we'll solve the quadratic. No problem. So n is 20. Find the sum of the squares of the first 10 natural numbers. First, write every time you see a question, write it as a series. Now you know, and we haven't done this yet, but there is a way of solving it, and I'll just quickly tell you the formulas. Sum of first n natural numbers we just learned. Sum of first squares of first n natural number is n into n plus 1 into 2n plus 1 upon 6. Okay. And similarly for n cube, n into n plus 1 upon 2 whole square. Basically, sum of first n natural numbers whole square. Now, this you need to memorize. So there is no other way. And I think this we already have understood. And n square is something new. So I guess the only thing to memorize is this. And you can always remember cubes. Sum of cubes of first n natural numbers was basically sum of first n natural numbers whole square. So this you will anyway remember. You can write it down in your notebook. Now, everything else will come from logic. For example, if I say that what is the sum of first even numbers? Got it? This we already did, first even numbers. And if you have forgotten, you can quickly write it like this, that if you take two common, this is basically 1, 2, 3, 4, 5, 6 only. and this sum is n into n plus 1 by 2, and everything was getting multiplied by 2, so sum will also get multiplied by 2, so n into n plus 1. Okay, everything you should be able to derive, because in questions in that pressure scenario you might be doubtful of what you remember, so you should know the logic. Now let's say sum of squares of even numbers. What does that mean? First write it down. 2 square plus 4 square plus 6 square plus 8 square and so on. Now we already know sum of squares of first and natural numbers, right? But we don't know this. Again, the same logic, you take 2 square common and you will see everything like this. This you already know, n into n plus 1 by 2. We just derived it, right? Sum of squares, right? N into n plus 1 into 2n plus 1, sorry. N into n plus 1 into 2n plus 1 by 6. And this 4 is here. So can I say 2 by 3 n into n plus 1 into 2n plus 1. This also I can ask you to remember, but you should not, because then it will become too much. Don't remember, just derive it like that. Understand with logic. Only thing that you need to remember is sigma sum of n, which also you can find out, sum of n square, which you have to learn, sum of n cube, which again you know, say sum of n ka whole square, right? And with this logic you can find out anything. And the only thing to remember is geometric mean, sorry, sum of geometric progression series, nth term of geometric series. And similarly, in arithmetic series, the only thing that you need to remember is sum of n terms and nth term. These are the formulas that we need to remember by heart. Now comes a third series, which is the only series left, harmonic progression, which is basically nothing but whenever the terms are in a way that the reciprocals are in arithmetic series. That's the only significance of harmonic series. For example, AP is 2, 4, 6, 8, 10 and so on. This is AP. If you make reciprocals of these, then this is an HP. That's it. So whenever we will stumble upon an HP, we will always make it a AP and then solve things. But if we have to get into the logic of it, can I say first term is this, second term is this, third term is this, fourth term is this. So nth term will be 1 upon A plus n minus 1 into D. This is your basic idea. And is there a formula for sum of n series? No. We will basically uh, find it by either taking the reciprocal, or we will stumble upon it during a question, but there is no need to learn the formula for Sn. And third thing, harmonic mean, just like we did AP in arithmetic mean was a plus b by 2, geometric mean was ab to the power 1 by 2 or root ab. Similarly, harmonic mean, if you have to find out, it will be basically this reciprocal of this, correct? So it will be 2ab upon a plus b. How? 1 by a plus 1 by b upon 2, and that too reciprocal. So a plus b upon ab, 2ab, or 2ab upon a plus b. This also you can remember as formula for harmonic mean. Now comes a very interesting part, which is always arithmetic mean of the same series will be greater than equal to geometric mean of that series, which will be greater than equal to harmonic mean of that series. And this is like one of the favorite topics of CAT, and we need to remember this. Okay. Now another thing that we need to know is geometric mean square is arithmetic mean into harmonic mean. It looks, how did we get here? But this is also very useful in questions, and we need to remember this as well. And with a very basic logic, you can see that this is true, because root AB, this was geometric mean of two numbers. A plus B by 2 was arithmetic mean of two numbers. 2AB upon A plus B was the harmonic mean of the two numbers. So AB equals to AB. So this is true, but you don't need to derive it every time. Just remember, geometric mean square is AP into HP. Sorry, AM into HM. Got it? We were on question number 6, right? First squares of first n natural numbers. I think we already did this. Sigma n square, which is n into n plus 1 into 2n plus 1 by 6. So basically 10 into 11 into 21 by 6. 2 za, 7 za, 5 za, 35 into 11 or create 5. Let's do question number 7. A, B, C are in AP. Okay. And A plus C. Now don't write A plus C. Can you write can you assume them as this? A, B, and C. You can assume them like this. Now it is saying A plus C, which is 2A. Why? Because A minus D plus A plus D, which is basically 2A. It wants me to write it in terms of B. B was already A, right? So can I say B is basically 2A? Correct? So it is saying A plus C in terms of B. A was basically B. So I can write that A plus C is 2B. I hope this is clear. It's nothing, it's just about the concept. So it told me ABC, but I saw them as this A plus D, and A minus D. And when it asked me to do A plus C, I got to 2A. And then I saw that B was A. So basically A plus C is 2B. Let's go. Arithmetic mean of 7 and 23. 7 plus 23 upon 2. So arithmetic mean is nothing but average. Find the geometric mean of 4 and 16. So basically A, B to the power 1 by n, which is in this case 2. So don't multiply and then see them in their smallest forms. This can be written as 4 into 4. So this 2 will come out, this 4 will come out, and 8 will be your answer. Again, whenever you are asked fifth term of an AP, so you can do A plus 4D is 23 and ninth term is 39. So A plus 8D is 39, and find the common difference. D we don't need A, right? So basically, can I do 2 minus 1 directly and get A eliminated? So 4D is 6 and 1, 16. So D is 4. Sum up to infinity. Why? Because obviously it's getting to a level where it will become very, very small, and we know sum up to infinity is a 1 minus r, provided r is less than 1, which obviously it is. R is what? R is half. So a is 8. 8 upon 1 minus half, or half. So ऊपर चला जाएगा, 16 will be sum up to infinity. Find the number of terms in the AP. So again, an is a plus n minus 1 into d. So you know an is 101, a is 5. I don't know how many terms are there, and the difference is 4. So 4n minus 4, or 4n plus 1 is 101, 4n is 100, n is 25. Understood? Find the sum of first 15 terms of an AP whose first term is 4, common difference is 3. Again, directly formula n by 2, 2a plus n minus 1 into d. Just be very comfortable with the formulas. Eliminate 2, 21, 25 into 15. Don't think before solving, just keep on at it. Got it? These are very basic questions, but they're important for your foundation. Then only we'll be able to go to level 2, and it really ups the game, because CAT is not going to ask us these basic questions, right? Now, before we go further, there is one more very important concept that we need to know. It's called arithmetic geometric progression. Arithmetic geometric progression, or AGP. This is basically what, let's say first number is 1, other number is 3, then it is 5, then it is 7. So this is an AP, because every time it's getting added by 2. And if it is 2, 4, 6, 8, 2, 4, 8, 16, 32, and so on, this is a GP. Now AGP is basically a mix of both. For example, 1, 3x, 5x square, 7x cube, and so on. If this is the numbers, you can see it's a mix. First part of the number is in AP and the second part is in GP. If I have to write it in a way, then I can write it as a plus d into x, a plus 2d into x square, a plus 3d into x cube, and so on, right? Now there is a formula, there is a lot of aspects to it, but you don't need to learn it, and you just need to know that okay, this exists. That's it, right? If there is, how do we solve it? There's a very nice way of doing it. For example, we'll multiply every number with x and we will push it forward and so on. This is also sum of n numbers, this is also sum of n numbers. Now we subtract. We will get 0 here, we'll get 1 as it is, we'll get 2x here, we'll get 2x square here, we'll get 2x cube here, and so on. So this will automatically become a, if you take this common, you can see that this is now a very nice GP itself. So this is a way of solving it, and we'll come to it in the advanced level when we go to the questions. But for now, whatever you've learned is more than enough to at least have some kind of a foundation. So let's just finish the number of questions that we have here. If the sum of first n terms of a series is given as this is not exactly AGP, but it is somehow not your AP, not your GP, not your HP. This is something else altogether, but there is a pattern to it. For example, if n is 0, the first term is 0. n is 0 doesn't make sense. 0th term का कोई मतलब नहीं है. N is 1. Then can I say A1 is 3 plus 2 or 5? N is 2, then 3, 4 plus 2, 12 plus 4, 16. A3 is 9, 27, 3 to the 6, 12, 13, 33. So if I get 5, 16, 33, I can never think of any pattern in it. But because it has given me the pattern, you can now appreciate that series can be of this way also, where you don't get to see the pattern at once. It's not your common AP, HP, GP, right? But it is given me, and this is not required. You don't need to write it like this. Basically, it is saying that sum of the first n terms is this. Find the fourth term. Now, if you remember at the start, what did I tell you? Don't find all the terms and then add the first four terms. Look it into this way, that whatever the sum till the fourth term is, and if I subtract the sum till first three terms, I'll get fourth term. For example, let it be A, B, C, D. I'm finding the sum of the first four, and then I'm subtracting the sum of the first three. I'm automatically getting the fourth term. And this is very, very CAT favorite. So you have to simply put sum up to four terms. There's no formula because it has already given me a formula. This sum of four terms. And this is sum of up to three terms. That's it. Now solve 16. Yeah, let's do it. So if you take 4 common, this is 12 plus 2, 14, and I took 4 common. And if you take 3 common, this is 9 plus 2, 11. So 33. This is 56. Any which way you can solve. The idea is that you don't really put values, find the first 4 terms and then add them. Or you find the fourth term, sorry, directly like that. What if it was asking 17th term? You're not gonna do it, right? You're not gonna find sum up to 17, and what I mean by that is you'll find sum till 17 and subtract sum till 16th. You're not gonna find individual digits to get till the 17th value. So this is also a very important aspect of solving these questions. Now find the sum of the first 8 terms of a GP. Again, when it has already told you it's a GP, what you will do is you will find the first term and you will find R as -2. Now it doesn't look like true, but it is true, because if you multiply -2 into -2, you'll get +4, and then you multiply -2, you'll get -8, and then you apply multiply by -2, it will become 16. So alternatively, plus and minus you will see. So you just need to understand this from whatever it has given. And since it wants me to find the sum of first eight terms, Sn is a into r to the power, again, r is negative. So can I say this will be the formula this time? A is 1, r is minus 2 to the power n, um, because n is given as 8, 1 minus 2. So this will basically be 1 minus, now minus 2 to the power 8 is basically 2 to the power 8. 2 to the power 10, I told you, you have to remember 1024. 2 to the power 9 is half it. 2 to the power 8 is again half it. That's why I want you to remember 2 to the power 10. So 256 upon 3. Why is it negative? It is negative. You can't help it. So don't overthink it. And all the options are also negative. Because the numbers that are coming later, they're much bigger. They're double in size. The negatives are more in value. So this is what? 255 upon 3. So 8, 16, 24, 15, 5 minus 85. Question number 16. Third and the sixth term. Okay, this is not an AP. Don't be this fast that you make a mistake. But don't write anything else. Write directly in our common ways that we've learned. Right? Now find our very, your first instinct should be what? Divide 2 by 1. So r to the power ar5 upon ar square. In fact, in exam, you should directly write this. Skip this step. But I'm just going slow because we are doing fundamentals here. R is 2. Can it be minus 2? Yes. But if the sixth term is 160, how can it be minus 2? It means R is a good positive greater than one number and it is increasing every time. So R is 2. Find the sum of all the multiples of 7 between 1 and 200. This is also a very common type. Obviously, it will not come directly in exam, but it can be a part of a bigger question. So basically, I need to find multiples of 7. First will be 7, then 14, then 21, then 28, and so on. Now, what about 200? So 200 is not divisible by 7, but 7 to the 14, 60, 7 8 the 56. So 4 is left. So I know the last number will be 196, which will be 7 into 28. This is 7 into 1. This is 7 into 28. So I know there are 28 numbers. So n is 28. R is what? There is no R. This is an AP, right? This is not a GP. So difference, can I say, is 7. A I know is again 7. So find the sum. Sum is n by 2. Again 2a plus n minus 1 into d, or a plus an, because I know an in this case, right? So 7 plus 196. N I know is 28. That's it. So 14, 6, 12, 13, 10, 2, 0, 3 into 14. Don't think twice, should I multiply or not? Just, your hand should not stop in the exam. 8 to 4 2. Again, this is important because harmonic mean से मुझे कोई मतलब ही नहीं है. I'll always convert into arithmetic mean. So you want harmonic mean of 4 and 6. I will find arithmetic mean of 1 by 4 and 1 by 6. Right? Always see it like that. Or in this case, because it's a very basic question, we have also learned 2ab upon a plus b. So we can directly do this also. So I can say it is 4.8. But if you forgot this, you know, I need to find 1 by 4 and 1 by 6 arithmetic mean and then make the reciprocal of it. So 1 by 4 plus 1 by 6 by 2, which is 10 upon 6, 12, 18, 24 into 2, 5. So 5 by 24, but reciprocal of it. So 24 by 5 or 4.8. But in this case, I remember the formula 2ab upon a plus b, so it's fine. Let's do now some really good questions which are of CAT level, but we will take them in the next session when we go to level 2. So now I hope that you have built some foundation around sequence and series, and you know how and what type of series it is, what are the basic formulas that you need to remember, and there should not be a second thought between assuming what the numbers are, because we will go with our standard notations. Now, this is not what question you can expect in the exam, of course, but when we go to level 2 and level 3, this will come very handy. So do the revision, go through this whole assignment and quickly finish it so that you are sure that you're ready for level 2. I hope this helps and thank you so much. Happy learning.